Okay, so on your quiz next week, and your test is going to be the week after next. Sometime this week, I'll put a study guide up, and you can just download it. But I have a practice for you next week. But you may want to start looking at it. And it just covers the worksheet. So if you did all the worksheets, you did it yourself, you should be fine. Okay. So those of you that know what my tests look like, you just look at your worksheet. All right. So number one, what are you going to do on your test and also on the quiz? How are you going to solve this equation?
You're going to subtract 3 from both.
Okay, so first of all, you got to know what equation this is, right? Because on the test, they're all mixed up. So some will be quadratic, some will be absolute value, some will be, at this point, we covered radical. So you have to know what kind of equation this is. So what kind of equation is this? It's a radical equation. So it won't say solve the radical equation, it'll just say solve each equation. And so you have to know it's radical, and so you got to remember, well, how do I solve the radical equation? Well, what are the steps? What's the first step? Isolate the radical. All right, so we can get the square root by itself. So when I do that, I got to subtract 3 from both sides. And so I get the square root of 5x minus 1 equals x minus 3. I can't do anything with x minus 3 because those are not like terms. So don't say that's a negative 3x. Don't say that's 3x. It is x minus 3. Okay, now once you isolate the radical, what is the next step? Raise both sides to a power equal to the index. Now for us, it'll be square root. So what's the index here?
2.
2. The index is 2. Square root. So I'm going to square both sides. Now, you guys keep in mind, I need to see as much work as possible. If you leave too much work off, I'm going to not see what you did, and you're not going to get full credit. So show as much work as possible. So you need to have shown this part, right?
Mm-hmm.
Now, I didn't have to see this part because I know you can go from here to here without difficulty. But I need to see this. I also need to see this. Now, the next step is to square, right? All right, so I need to see that part. Now, some of you can go from here to the next step without doing anything else, and that's fine. So for example, on the left side, now all of you need to do the left side without any work,
Right.
because when I square the square root, they undo each other. So what's the expression that's left? 5x minus 1. Now, some of you can in your mind go ahead and square this binomial, but you got to be careful. Others of you may have to write it out. Then write it out. But you don't have to show this work that I'm about to do. So you would say x minus 1 times what? I'm sorry, x minus 3 times what? X minus 3. And then you FOIL it out. So I get x squared. What's the outer? Minus 3x. What's the inner? Negative 3x. And what's the last? Plus 9? All right, when you combine your like terms, I get x squared minus 6x plus 9. Okay? All right, now that goes here, right? So I have x squared minus 6x plus 9. Okay, so I went from this equation, a radical equation, to this equation. Now, what kind of equation is this? It's quadratic. So now you have to go to the quadratic mode. How do I solve a quadratic equation now? Well, you got to put it in standard form. And so when I put this in standard form, I'm going to subtract 5x from both sides, and you don't have to show this work right here. So I'm aligning my like terms. So I get negative 1 is equal to x squared, and a negative 6x and a negative 5x is a negative 11x, and then plus 9. Okay? All right, then what's the next step? Add 1 to both sides. And so I get, now remember there's something that goes there. What goes there? 0. So 0 equals x squared minus 11x plus 10. So you got to know the mode that you're in at that point. So I went from a radical equation. I tried to remember how do I solve this radical equation. Then I did all those steps and end up with a quadratic. Now I have to go to how I'm going to solve this quadratic equation. So you have to know what kind of equation you're dealing with. Okay? Now, we mentioned in class that the radical equations you're going to have with these, the quadratic equations you're going to end up with a radical equation will be factorable. So you can factor this. If you want to use quadratic formula, you can, but it's factorable. So I'm also going to go ahead and put everything on the other side. So I'm just going to transpose the sides. So do y'all agree that 0 equal x squared minus 11x plus 10 is the same thing as saying x squared minus 11x plus 10 equals 0? Okay, left equals right, right equals left. Okay, now let's factor. So when I factor this, what are my factors? The last sign's negative. The last sign's positive. These signs have to be the same. They both have to be negative. What do you think it is? 10 and 1. So x minus 10, x minus 1. And then on your first worksheet or your second worksheet, whatever it was, what was the next step you did there? Set each one equal to 0. So you use a zero factor property. So I get x minus 10 equals 0, x minus 1 equals 0. And so notice when I started out, I went from a radical equation, I had to figure out how to do this, to a quadratic equation, then I have to remember how to solve that, and then I am now down to linear equations. So what's x here? 10, and what's x here? 1. All right, so now if you're not careful, some of you are going to say, well, those are my solutions. But when you raise both sides of an equation to an even power, not odd, an even power, what are sometimes you introduce? What is that called?
Extraneous solution.
Extraneous solution. Right, extraneous solution. All right, so I'm going to pause this for a moment, and I'm going to ask you just like last time. Okay, so what can you introduce at times? Extraneous solutions, extraneous roots. Okay, so what do you have to check for? Extraneous solutions, extraneous roots. So you got to check these solutions. Where do you go back to check these solutions? To the original. To the original. They may both work. One may be a solution. They may not both work. Okay, so you have to check them. So let's check x equal 10. All right, so when I go to x equal 10, right here, I get the square root of 5x minus 1 plus 3 equal x. So where we see the variable x, what do I substitute? 10. So I get the square root of 5 times 10 minus 1 plus 3, and I want to see that's going to equal x. And what's x? 10. All right, well, what's 5 times 10? 50. What's 50 minus 1?
49.
What's the square root of 49? 7. So I have 7. What's 7 plus 3? 10. So that's a solution. All right, so in the blank, you would say x equal 10 is a solution. All right, now let's check x equal 1. Go back to the original. So write down the original, which is this. And where we see the variable x, what do you substitute? Substitute 1, right? So I get the square root of 5 times 1 minus 1, that's times, plus 3 equal 1. So I want to see the left side is going to equal the right side. Well, what's 5 times 1?
5.
What's 5 minus 1?
4.
What's the square root of 4?
2.
2 is 2 plus 3, that's a 3, equal to a 1. No. So the x equal 1 is a solution. Now, keep in mind that those are solutions to something. They're both solutions to these linear equations. So x equal 10 is a solution to this linear equation. X equal 1 is a solution to this linear equation. They're both solutions to the quadratic, but they're not both at the same time solutions to the radical. Okay? They're both not solutions to the radical. So that's why you need to check your solutions. So this is called an extraneous root. Okay, an extraneous root. Okay. So the only solution is which one? 10. The only solution is 10. Okay, so that was number 1. Any questions on that? So that's a review from last time. So quite a bit of work. And notice in the process, you could easily mess up at some point, so you got to be careful. Okay, now let's look at the next one. So the other one's going to be an absolute value equation. All right, so let's solve this equation. There's number 2. All right, so 3x minus 2, the absolute value 3x minus 2 plus 5 is equal to 8. All right, now there's a certain way you got to write your mathematical notation, and you got to make sure that all of your statements are mathematically correct. Okay? So, now I have an absolute value equation, so now you got to go to the absolute value mode. What are you going to do? Subtract 5 from both sides. All right, so when I subtract 5 from both sides, I get the absolute value of 3x minus 2 is equal to 3. So the absolute value of 3x minus 2 is equal to 3. All right, so then what's the next step? You do what? You're going to rewrite this with how many equations? 2. With or without the absolute value bars?
Without.
Without the absolute value bars. Okay? So tell me what to write. 3x minus 2 equals 3 is one of them. What's the other? 3x minus 2 equals a negative 3. Very good. All right, so this is what you would have. You have to write this. You have to say 3x minus 2 equals 3, and 3x minus 2 equals a negative 3. Because remember, absolute value, the absolute value of a number is the distance the number is from 0. So you can go to the right, you can go to the left. So hence, positive 3, negative 3. Yep. Now, here's what some of you are doing, and here's why this is incorrect. So some of you are doing this. And in the video, we never did do that. You're doing this. You're saying, all right, well, that's the same thing as this. 3x minus 2 equals 3. Absolute value 3x minus 2 equals a negative 3. That's a negative 3 right here. Well, that's not true. Because this right here has 2 solutions. Now you're saying this. You're saying, all right, this right here is the same as this. Well, these two. Well, you just rewrote this over. But then you do this as well, which this has no solution. Because the absolute value of a number is either 0 or what? Positive. It is never negative. So do not do that. Do not rewrite it with the absolute value bars. Because you're going to be very upset when you lose some points. Because mathematically, that's not a correct statement. This and this are not the same thing. This has solutions. How many does this have? 2. This right here that I'm pointing to has none. How can they be the same? Okay? All right, so the way you write things are important. All right, so remember, you're going to rewrite it without the absolute value bars, and that's where practice comes in. So you do the same worksheets over and over. Print them out. That's what I did. I did the same problem 5, 6 times. Of course, back in the day, you didn't have all this stuff that we now have.
Shooter. Shooter.
All right, you have to find things to do. All right, so you add 2 to both sides. So 3x equal 5, and so what's x? 5 over 3. All right, now do you have to check the solutions? No, the only time that you are forced to check the solutions is with which kind of equation. Radical equation in which you raise both sides to even power, which you do, because you're dealing with square root. Now, even for some of you that are checking your solutions, you're not checking them. If you did check these, you spent the time to do this, you're still not doing this correctly. So let's check it. Let's do this. So let's go quickly and check 5/3. Go back to the original. And I'm just going to do it here. So in your mind, you think about what this is. What's 3 times 5/3? If you're in college algebra, tell me what that is. 5. Thank you. What's 5 minus 2? 3. What's the absolute value of 3? What's the absolute value of 3? 3. 3 plus 5 is 8. So that works. Did you have to check it? No. All right, let's do the other one. So I'm going to add 2 to both sides. So 3x equal -1. So what's x? -1/3. So that's my other solution. And again, you don't have to check it. If your algebra is correct, your steps are correct, you're fine. But let's check that one. You don't have to, right?
No.
Okay. So don't, on the test, don't waste your time. If you're running out of time, don't waste your time checking. The only one you have to check are the radicals. All right. So I want to go back to the original right here. So you get 3 times a -1/3 minus 2, right? Absolute value of that. Whatever that is, you're adding what? 5. And you want to see if that's going to equal what number? 8. All right. Well, look at this. What's 3 times a -1/3? -1. Okay. What is a -1 and a -2? -3. What is the absolute value of a -3? 3. And what's 3 plus 5? 8. All right. So -1/3 works. Okay. All right. So that was a quick review from the last class period. So on your quiz next week, just make sure you can do those. Okay. All right. So that takes care of that one. You should be okay for next week with this.